Okay, so in 9.2, number 1, they're really asking me, are the functions sine of 3t and 3 sine of t different?
So
Equal
to
for
each
all
other.
values of t.
Yeah. So if I think about them as functions, right? To be the same function, they would have to take the same inputs to the same outputs for all the inputs, right? And they would have to have the same domain. Does that make sense? Okay, so what do you think? Are these the same or different?
No,
Different. Why?
because if you plug t equals 1 in, you get different answers.
Yes, so you put 2 in there.
If you plug t equals 1 in, how'd you calculate the sine of 3?
You're using radians.
Yeah?
Let's just put
You
it
use a
back in.
calculator? Okay.
Yeah.
Just shove it in a calculator. Okay, so, yeah, sure, that'll work. The calculator can evaluate functions most of the time. What else could you do? So you could plug 1 in. What else could you pick?
90.
I was kind of
Yeah,
thinking
well,
replacing
well,
sine with
special
a.
triangles
Yeah.
actually work better, but
Yeah, so
some nice round.
I'd probably pick some nice, easy angle, right? So that I can plug it into sine of t easily. What else should I pick? What else do I want in that angle? I better be able to do 3 times that and plug it into sine easily.
So 30.
Yeah, so 30 would be a great choice, right? You guys see that? So that would be a good test case, right? So let's try that. So trot out your 36, oh, that's not a 3069 triangle.
We believe you if you told us it was.
No, you wouldn't. You guys do have a history of complaining about poorly rendered triangles.
Like this one.
Like this one. Okay, so trot out your 30, 60, 90 triangle, labeled in labeled in radians. And then what? I want to calculate 3 sine of, so I'm just going to think, right? T is pi over 3.
Pi over 3 is 60 degrees.
Good. So we're going to think T is pi over, why did I label the wrong frickin' one?
Because it's.
You're worrying about your triangle.
Because I was being nagged about my triangle. All right, so I got T is pi over 6. So what's the sine at pi over 6?
1 over 2.
1 over 2. So what's 3 sine of t then?
3 over 2.
3 over 2. You guys with me on that? Okay. How about on the other one?
That's
Yeah.
the sine of 3 pi over 6, which is definitely not
So if t is pi over 6, then 3t is 3 pi over 6, which is
a 90 degree angle.
pi over 2. I think 3 over 6 is 1 over 2. And then I'm going to take sine of that, right?
That's 90. Or I mean 1.
So this should be sine of 90, which is 1,
Which is a whole half less.
which is definitely not the same. You guys with me on that? Maybe the best tool here would be just to note something like this, right? What are these two functions doing? They're both made out of,
The same parts, but in different orders.
yeah, they're made out of the same parts in different orders, right? So that one can be the primary.
Yeah.
Call that one the black one. So that one does sine of t and then multiplies by, or sine, right? And then multiplies by 3. And the other one does what?
Multiply by 3 and then sines.
Yeah, so that one multiplies by 3 and then sines things.
You can think about it graphically too, because a stretched sine wave is definitely not the same as a compressed one.
Perfect. Badass. Yeah, so you could draw this picture and then remark order frickin' matters, right? Or you could compress a sine wave horizontally by a factor of 3 and then stretch one out by a factor of 3 vertically and note that those are different. That would be another cool approach. Cool? Any other questions, thoughts? Anybody got a different way to see that yet?
Which one would you prefer on a test?
Don't care.
Okay.
It should be noted that not all functions does the order matter.
Yeah.
Hashtag not all functions.
Yeah, so sometimes, right, you can swap the order and that's okay. It's not particularly often. The sets of functions that commute like that are pretty small. But you should be aware that there are some. So just knowing that they're the same steps in different orders doesn't necessarily mean that they won't be the same function. It does kind of strongly imply it, like wink and nudge at you a little bit. Cool. The graphs is perfect. I think all they wanted for this one was for us to try a value. And so I would say pi over 6 is perfect. Cool. Questions, thing?